There are many ways to solve the problems with the logarithm. Let's take a look at this one. In this case, I would move this logarithm to the left side and 1 to the right side. So let's take a look what I'm going to have. Logarithm x squared minus 9 minus logarithm x plus 3 is equal 1. These two logarithms have the same base. That's why I'm going to use the property for the logarithm of quotient. The difference of two logarithms I can rewrite as log of quotient. So that's why I'm going to write the left side as logarithm of x squared minus 9 over x plus 3 equals 1. Please notice that in the numerator we have x squared. Okay, so that's why I'm going to factorize the numerator, and I have logarithm x minus 3, and I have x plus 3 over x plus 3 equals 1. X plus 3 and x plus 3 cancels out, and I have logarithm x minus 3 is equal 1. Now I can convert the logarithmic form to the exponential and simply write that this is 10 to the first power is equal x minus 3. I'm going to move negative 3 to the left side, and I'm going to have 10 minus 3 is equal x. So x is equal 7. Let's take a look how it's going to work in the original equation. X squared means 7 squared is 49 minus 9 gives me 40. The domain is going to be positive for this logarithm. X domain has to be always positive, so this logarithm is okay. Let's take a look at this one. If I'm going to have 7 plus 3, this is 10. Again, I'm going to have positive domain. X, the domain of the logarithm, must be positive. So this logarithm is also okay. That's why this is the final solution to my problem.